video is going to focus on volume and surface area of rectangular prisms and cylinders. So the first thing we need to start out with is just some basic vocabulary. So the surface area of a shape is just the sum of all the surfaces of a three-dimensional figure. And some of the key words that help us identify that a problem's asking us to solve for surface area are cover, wrap, paint, surface, or square units. So you can imagine if you are going to wrap a present for somebody, the amount of wrapping paper that you're going to need to wrap the actual gift is going to be something that you would solve surface area for. Whereas the volume of something is the amount of space that is occupied by a figure. So some of the keywords for volume are fit, fill, space, hold, amount, inside, contain, and cubic units. So for volume, that would be something like how much does this jar of jelly beans have inside of it? So how many jelly beans are in it? The amount of space that's being taken up by that object. So the formulas that you're going to be using are all going to be listed here. They're going to all be given to you during your SOL test. So you can access your formula sheet that has all of these formulas on it, but they're also listed here while you're working on the notes today. So one thing that you really want to keep in mind when you're solving all of these is that we're going to use pi approximated to 3.14. So you're not using a pi button on a calculator for these, you just want to use the decimal 3.14 to get your answers rounded nicely. The volume of a rectangular prism, so first of all, a rectangular prism is something that looks kind of like a cube like we see here. So it could be a cube or it could be a rectangular prism where it's not a perfect square on the base. But we have a length, a width, and a height for these. And to find the volume of that shape, we use V equals LWH. This just means volume equals length times width times height. So basically what you're doing is just multiplying all of those dimensions by one another. So when you see those letters up against each other, remember you can assume, oh yeah, there's like the little multiplication sign in between there, so I just need to multiply those numbers. Now for the volume of a cylinder, so how much is inside of a cylinder, we have V equals pi r squared h. So again, we're just multiplying here, but we're multiplying pi times r squared times h. So r in this case is the radius. So r means radius. And if you remember, radius is only half of the distance across a circle. The entire distance across a circle is called the diameter. So to find the radius, you just have to take half of the diameter. So if they give you the whole diameter for this problem, then you would have to divide it into two pieces to figure out what the radius is before you can use this formula. H here just means height, so how tall it is, just like the H in the rectangular prism. So not too hard to transfer between the two shapes there. So the volume of a cylinder here has pi times r squared times h. So when you're going to solve this, you have to take the radius squared and do that first, because you have to remember that we use GEMDAS. So it's been a while since we've kind of like talked about that actual formal process, but it's something that you have to follow whenever you're simplifying an expression. So you have to use your exponents or take care of those exponents before you multiply. So do exponents before multiplication. So whatever your radius is, square it first, and then you can multiply the pi times the height times the radius squared. Now, as we get into the surface area, so we just covered volume, that's all about filling an object, but the surface area is the amount of the outside of a shape. So we said like the wrapping paper on a box if you're going to wrap a present for somebody. So the formula for that is surface area equals 2 times the length times the width plus 2 times the length times the height plus 2 times width times height. So what I have drawn here is the net of a rectangular prism. So a net is just a shape but unfolded, so all the faces are shown. So you probably have seen this in the past. But it basically, if you unfolded all the sides of this, you would get all of these different layers of it. So I kind of broke it down just so you can see what we're talking about for the surface area of a rectangular prism. So this first side right here is just your length. So all of these lengths here are just your actual length of whatever the shape is. So whatever length is given, that's what we have for our length there. These measurements here are the width, and the width is also up here. But then if you go to fold this, here's your height, and this will also be the height because those are going to fold into one another. So they're both the height, which means both of these are the height as well. So same down here. So the reason that this surface area formula works is because our first part is talking about 2 times the length times the width. Well, the length times the width is just the area of this top rectangle right here. So we have 2 where we have to find the area of both of these. So 2 times length times width gets you these first 2 pieces. So far the area of just those 2 rectangles. Then we have to do 2 times the length times the height. Well, that's this one right here and this one right here. So we have length times height and length times height to find the volume, or sorry, the area of both of these 2 pink rectangles, and there's 2 of them, so that's why we have 2 times length times height. And then of course that last piece is 2 times width times height, and that's just these end pieces here. So these 2 blue rectangles now, we're getting the area by multiplying their width times the height, but there's 2 of them again, so we have 2 times the width times height. So that just kind of broke it down for you to understand how this actually works. We're just getting the area of each of these little faces and adding them all together to get the entire surface area of these rectangular prisms. So we have a similar idea when we get into our cylinder. The cylinder has a circle on the top that we need to find the area of, and a second circle on the bottom that we need to find an area of. And that is this first part of our formula right here, 2 times pi r squared. Because to find the area of one circle, you do pi r squared, but since we have 2 of them, we have to multiply it by 2, so 2 pi r squared. So that takes care of that piece. Now the rectangle part here is a little trickier. So when you have the net of this shape, this rectangle piece kind of gets unfolded, and this part is just the height of whatever your cylinder was. But this distance across here, I know it's kind of hard to see it, I highlighted over that. Oops, let's get the eraser. So the distance here is 2 pi r squared. And that's because that is taking care of that whole distance around a circle, which if you remember the entire distance around a circle, it's called the circumference. Well, the circumference of a circle is just calculated by doing 2 pi r. So we have this whole circumference as the side of this rectangle times the height of the entire cylinder to get the area of this rectangle. So we're getting the whole area of the rectangle times, or by multiplying the circumference by the height. So that's where the pink part comes from. And when we add these all together, we get the entire surface area of our cylinder. So that's just an explanation of where we're getting those formulas from. And again, you don't have to memorize these because you'll be given a formula sheet anytime you're asked to solve them. As we move on to some examples, you're going to want to be able to access that cover sheet in order to figure out, well, what are these formulas so that you can write them down and go ahead and use them. So let's try this first one together. It tells us to find the volume. So step 1 tells us to look at the formula sheet and write the formula. It asked us for volume, and we're dealing with a rectangular prism, so I'm using volume equals length times width times height. And then step 2 says replace the formula equation with the appropriate numbers. So volume equals, I need to figure out what is my length. My length here is 10, my width is 2, and my height is 5. So then all I have to do is everywhere I see L, I'm going to put 10. I'm going to replace my W with a 2 and my H with 5. And then all I have to do is look at how I'm going to simplify this. I have 10 times 2 times 5, so since I just have all multiplication, I can do it all in one step. 10 times 2 is 20, and 20 times 5 is 100. So I get 100. But my volume always needs to be labeled with cubed units. So I was talking about centimeters, but since I'm talking about space, I'm in the third dimension here. I need to have centimeters cubed. So it's like how many cubes could I fit in here? I could have 100 square or 100 like little centimeter cubes in that box. So if you want to pause and try the next one on your own, you're more than welcome to, or you can just listen along and try it with me. So again, it says find the volume, and we're still dealing with a rectangular prism. So I'm still using the same formula of volume equals length times width times height. This time my length is 7, my width here is 1, and my height is 2. So I do length is 7, so 7 times 1 times 2. I just replaced all of my letters with their numbers. So L was 7, W was 1, and H was 2. All we have to do is multiply here. So 7 times 1 is 7, and 7 times 2 is 14. So 14, and this time I'm dealing with inches, but it needs to be inches cubed because we're talking about volume. So our final answer is 14 inches cubed. When you're deciding which is the volume, or sorry, which is the length, which is the width, which is the height, it doesn't really matter which one you pick as which, as long as once you decide what it is, you're consistent with it throughout the rest of your problem. That's okay. So in our next problem, we have the same shape that we saw in our first example together. So length was 10, width was 2, and my height was 5. But now it's telling me to find the surface area. So I'm still dealing with rectangular prisms, and this formula is surface area equals 2 times length times width plus 2 times length times height plus 2 times the width times the height. So I have all of these things that I need to multiply and then add together. So the first step is taken care of. I wrote my formula down. Step 2 says to fill in all the numbers with what you know. So 2 times the length of 10 times the width of 2 plus 2 times length of 10 times height of 5 plus 2 times the width of 2 times the height of 5. So I just filled in everything I know, and now to use GEMDAS, I have to take care of all my multiplication before I'm allowed to add. So surface area will equal 2 times 10 times 2 gets us 40. My plus sign comes down. 2 times 10 times 5 is 100. Plus sign comes down again. And then 2 times 2 times 5 is 20. So now I have 40 plus 100 plus 20, and surface area equals everything added together, which is 160. And it's telling us we have to always label our surface area problems with square units. So whenever we talk about area, it's square units. We had centimeters, but it's centimeters squared because we're talking about the area that is covering this entire shape. So again, if you want to pause and try the next one on your own, you're more than welcome to, or you can just listen along to see how we do it. So problem says find the surface area. We're still using surface area of a rectangular prism formula. So it's the same formula we just used above. So you can copy it down for step 1. The length here is 7, the width is 1, and the height is 2. So I'm going to go ahead and fill in all of my letters. So 2 times the length is 7 times the width is 1 plus 2 times length of 7 times height of 2 plus 2 times the width of 1 times the height of 2. So I just replaced all my letters with what I had labeled them as. So L was 7, W was 1, and H was 2. So again, we have multiplication and addition. We have to follow GEMDAS and take care of all the multiplication first. So 2 times 7 times 1 gets us 14. 2 times 7 times 2 gets us 28. And 2 times 1 times 2 gets us 4. So when we go ahead and add all of this together, we get a total of 46 feet squared as the entire surface area of this rectangular prism. Go ahead and flip to the next page, and we're going to talk about cylinders and their volume and surface area. So we have a different type of shape, but our steps are still the same. So the first step is always to figure out which formula you need to use. So we're talking about volume first, and this is for a cylinder. So the volume of a cylinder formula is volume equals pi r squared h. So we have this exponent that we're going to need to take care of first every time. So volume equals pi. Remember, we replaced pi with 3.14. We're going to multiply that by the radius squared. Our radius is given to us as 4, so 4 squared. And then we're going to multiply that all by the height, which is 12. So using GEMDAS, we bring down 3.14 and our multiplication sign, and we take care of our exponent. 4 squared means 4 times 4, which is 16. Bring down the rest Once we have all multiplication, we can just go ahead and multiply everything together here, and our volume becomes 602 and 88 hundredths, and we are talking about centimeters cubed because we're back in volume here, so we need cubic units. If you want to pause and try the next one on your own, you're more than welcome to. We have the volume of a cylinder here, and this time the height is 13, that's how tall this shape is, and the radius is 15, it's half the distance of the circle that is on the top and bottom of this cylinder. So we're still using the volume equals pi r squared h formula, and this time when we fill it in, our radius is 15, so we're squaring 15, and then we're multiplying it all by 13. So we take care of GEMDAS by finding our exponent's value first. So 15 squared means 15 times 15, which is 225. Now that we've taken care of all of our exponents, we just have multiplication left. So when we go ahead and multiply this all together, our final answer becomes 9,184 and 5/10, and we are talking about inches cubed for volume here. Now in our last set of examples, we are still dealing with cylinders, but this time we're finding the surface area of them. So we have height of 12 and radius of 4 in this example, but we're finding the surface area of a cylinder, so we're using the formula SA equals 2 pi r squared plus 2 pi r h. So our first step is still just to fill in all the numbers that we know. So 2 times 3.14 times the radius squared. Our radius here is 4, so 4 squared, plus 2 times 3.14 times the radius times the height. And then I'm going to take care of my exponents first. So I have 2 times 3.14 times 4 squared is 16, plus no exponents here, so I could just multiply these all together. Or we can just show that they're still being multiplied here. So in my final step, I just have to complete my multiplication and then I can do my addition. So when I multiply this first chunk together, 2 times 3.14 times 16, that gets us 1,413, plus 2 times 3.14 times 15, or sorry, times, I have the wrong number. I'm looking at the wrong example. We have, sorry, this first chunk gave us 148 hundredths, and then the second part here gives us 301 and 44 hundredths. When we go ahead and add those all together, we get 401.92, and we are talking about feet squared because we're back on area here. So that's your example for finding the surface area of a cylinder. There's a few more steps here just because you have an exponent, multiplication, and addition. So just make sure you're following GEMDAS as you go through these. Feel free to pause and try the last one on your own. We are still using surface area of a cylinder, so SA equals 2 pi r squared plus 2 pi r h. So this time my radius is 15 and my height is 13. So 2 times 3.14 times 15 squared plus 2 times 3.14 times 15 times 13. We take care of our exponents first, so we have 2 times 3.14 times 225 plus 2 times 3.14 times 15 times 13. In our last step, we need to take care of this multiplication. So here, when we multiply all these together, we get 1,413, plus when we multiply this section together, we get 1,224 and 6/10. Adding everything together, we get 2,637 and 6/10, and we are dealing with inches squared for surface area. So make sure you're following GEMDAS, using the correct formula for your shape, and label your the dimensions of your shape as you go along so you don't make a mistake in filling in which letter is which number. So take your time and make sure you're checking your formula sheet. Thanks for watching.